All right, in 3.2, we're talking about how to solve systems by graphing. So when it is in slope-intercept form, like we see in problem 1, it's pretty easy. All you have to do is start at your y-intercept and do what the slope tells you. So for the green highlighted one, we're going to start at -2 on the y-axis, and we have to travel up 3 over 1. I'm going to make another point up 3 over 1. Again, you can make as many points as you want. I just require a minimum of 3, but obviously the more you have, the more accurate your graph will be. Then you want to connect these points with a line. And then we're going to go on to the one highlighted in orange. The one in orange, we start at 5 for my y-intercept. My slope is -1 over 2, so I go down 1 and right 2. Then I go down 1 and right 2, and I can keep going. But we can already see that they're going to intersect at this point right here. And so if we look at the coordinates of the point of intersection, remember that point where they intersect is my solution right here. So we're going to have the solution at 2, 4. All right. So we know that 2, 4 is the solution because it's where they intersect. And again, we also know that if I plugged in 2 for x and 4 for y, I would get a true statement. Let's just try it out. If we plug in a 4 for y and a 2 for x, this gives me 4 equals 6 minus 2. And we know that 4 does equal 4. All right. If I plugged it into the orange one as well, we would also get a true statement. All right. The nice thing about graphing, though, is that all you have to do is draw these two lines and then see where they meet on the graph. Next one, number 2. Now, in number 2, these are not in slope-intercept form just yet. So I'm going to have to change them into slope-intercept form. So the first one, I'm going to take this 5x minus 3y equals 12. I'm going to start by subtracting 5x on both sides. That gives me -3y equals -5x plus 12. I'm going to divide both sides by -3. When I do this, we get y equals 5/3 x minus 4. All right, so I'm going to start at -4, and I'm going to go up 5 over 3, up 5, 1, 2, 3, 4, 5 over 3, and there is my first line. Then I'm going to go ahead and I'm going to turn the second equation into slope-intercept form. So I'm going to start by adding 10x to both sides. That would give me 6y equals 10x plus 6. I can then divide everything by 6. And we're going to get y equals, if I reduce 10/6, that gives me 5/3 x plus 1. Now, I already know that my answer should be no solutions, because if I look at the slopes, I see the same slope, and so I know that these are parallel lines. We talked about if we have parallel lines, we know there's going to be no solution. But if I were to graph this, we start at 1, we go up 5 and over 3. I kind of run out of space if I go up 5, so I'm going to do the exact opposite. I'm going to go down 5 and then left 3. And we can see that if we connect these points, that these lines are never going to intersect because they are parallel to each other. So for this one, we're going to have no solutions. All right, and then number 3, again, we do need to make sure that we turn these both into slope-intercept form. The second one is already in slope-intercept form, but the first one is not. So I'm going to have to go ahead and change this. I'm going to start by subtracting 2x on both sides. That gives me 3y equals -2x plus 9. We're then going to divide everything by 3. And if we do this, we get y equals -2/3 x plus 3. So if I start at 3 on the y-axis, we're going to go down 2 and then right 3, down 2 and then right 3. I can go ahead and connect these with a straight line. And now I can go ahead and I can draw my second line, which I start at 3, and I also go down to right 3, down to right 3. And we actually see that these lines are going to be the same. You can see right here that they match up perfectly. One was just kind of hidden because it was in standard form. So because these are the same line, we actually know that we're going to get infinite solutions. All right, another way of saying this would be all real numbers, so you could use the this all real number symbol, but either of these would be good answers. I would be okay with either of those.